All right. Good morning, everyone. I'm glad to be here. Bit excited. I haven't been on a stage in over a year and a half. And I don't know, let's get started. I hope I won't screw up too much. So a little bit about myself. Who am I? Why am I here? I'm a family man. I'm a digital nomad. Some people have asked me about where I've been and stuff. I travel the world with my family slowly. So this is us in Vietnam this summer. And I am also an opinionated guy. I do mostly front-end and web. I'm a consultant, architect, engineer, mentor, blah, blah, blah stuff. This is how you can find more info about me and contact me. And I work through Code Value. So a little bit about my background and why you should perhaps listen to my opinions. Over 10 years of web development, mostly in the front-end world. A variety of targets, web, mobile, responsive, APIs, some backend, but mostly not. I've been working on websites, apps, widgets, integrations, just about everything out there in the wild web, I did. Companies, small to big startups, companies who have gone through massive growth while I was working there, corporations, all sorts of businesses, product companies, projects companies, consulting. And with each and every company or client, I have seen different technologies, back-end, front-end, a lot of stuff. I have been an employee, a team leader, a technical lead. I am now mostly a consultant. I have worked most of my career on-site in offices, but also remote a long time ago, and also during the past year and a half. And basically, I've seen some shit. During the last few years, I have led teams in 2 dimensions. One is technological, which is easy. So I architect and choose technologies to help my clients succeed. I try to lay a solid foundation, which hopefully won't need to be thrown away and be rewritten after a short time. And the other dimension is cultural, which is dealing with people and organizations and how they interact with code. And that is the hard part. I try to improve individual and organizational development speed and quality, and I explore the complex interactions between code, people, culture, and organizations using tooling, rules, conventions, things like that. So the title of the talk is Best Practices for Front-End Teams Delivering Fast and High-Quality Modern Apps at Scale. Thank you for Code Value for organizing this event. Thank you for Microsoft for the space, for this stage and opportunity. I'd like to emphasize that the target audience for this talk is senior developers, team leaders, tech leads, architects, but titles are really dumb. And they, I can call myself a CEO, CTO, or whatever. So really, it's for anyone who cares and think about how people, code, and organizations interact in delivering software. You should know, worry, or care about pull requests, code reviews, maintainability, quality, and development speed. That's what I'll be discussing. So the topics I'm going to cover is mindset and guiding principles, cultivating team and organizational culture, tools and methodology, and a whole lot more stuff that I would have liked to discuss but don't have the time today. But a very detailed and way too long blog post is coming up, and I hope it'll be published within a reasonable time of a few days and not weeks, but I can't promise. This is not repeatable topic, because a lot of concepts and issues and solutions can be applied in different ways. So some of the stuff I will be repeating, and that's by design. Now, a lot of it is also obvious, and like, you know, you should care about code quality, duh. But sometimes stating the obvious is necessary, and giving it the proper attention. So let's proceed. Mindset and guiding principles. I personally believe, and it has worked very well for me, in the Unix philosophy. That is, do one thing, do it well, compose those small things. Avoid monolithic, opinionated, and generally hard to replace parts, modules, frameworks, you know, whatever. Prefer small, single purpose, and modular parts, which can be easily replaced and swapped, or, you know, built upon, wrapped, you know, modified. Don't reinvent the wheel. You can probably reuse most code for whatever it is that you're building and doing. And nowadays, in the open source culture that we have, we actually do this. But still, it's important to say that, you know, given any problem, any challenge, don't run, first of all. Don't try to solve it, you know, yourself. See whether someone else did it. Do your research. And basically, most software is writing glue code, which is unique to your product, using a whole lot of parts from which other people have written, tested, and validated for you. Roll your own as the very last resort. So, this is basic. Learn the basics. Knowing the building blocks allows us to meaningfully understand abstractions and manage their trade-offs instead of blindly following hype or using whatever it is that all the hipsters are doing nowadays. And a sad example of that is how most web developers, very unfortunately, don't know HTML and CSS beyond a very basic level. Like they know the syntax, but they don't really even know the, I don't know, 30, 40, how many HTML tags are out there. They don't care about it, and they create problems for themselves, which usually manifest themselves later down the line. Stuff like div soup, and bad accessibility, and CSS specificity, and Z-index wars. You know what I'm talking about, right? CSS specificity wars. And can you guys please lift a hand who's had to deal with that nightmare? You? Hype. Try to avoid it. Don't adopt everything new and shiny. See whether something gains real-world traction before you start testing it, seeing whether it actually solves your problem. Give new technology time to mature. That is not to say that you shouldn't adopt everything that's new and cool. If there's something that is, I don't know, groundbreaking, and your use case is solved specifically by that, and there is nothing like it, sure, be an early adopter. But that is usually not the case. Have new stuff battle-tested and polished at someone else's expense, someone else's time, bugs, and QA, and headaches, and, troubles. A good example for that is CSS in JS. I'm a fan. I have a talk about it. I have spoken about it previously. It took years for CSS in JS, for the very good and novel idea of CSS in JS to mature into a very good implementation, which is actually worth using nowadays and is worth the trouble of learning and going through the setup, and is totally worth it today. But that was absolutely not the case in the first or second or third generation of CSS in JS. It takes time to iterate and improve. Another good example is web components in Polymer, which, I don't know, they were crazy hype about them 5 or 6 years ago. I remember being excited about it. But then I did not see anyone use it in the wild for years. And you know what? I don't want to discover why nobody is using it. But I guess there's good reasons for that. I don't want to pay that price. Which brings us to popularity is not a sign of quality. Now, it obviously can be, but it isn't necessarily. Most people do something just because everyone else does the same, for better and worse. Don't do that. Use tech which actually solves your problem. Okay? Don't just use blindly stuff that everyone else does. A bad abstraction is worse than no abstraction. And adopting and relying on something which is bad will cost you a lot for a very long time. It is basically technical debt. You adopt something too early, not a good thing, you'll have to carry that load for a very long time, either for it to improve or for you to change your mind and understand that it was a mistake. This is a very personal point for me. So if you think that something sucks, something popular, feel free to avoid it. Nowadays, unlike years ago, I can say proudly that I have actively avoided Angular 1 and more recently Redux, even though during the last few years, absolutely everyone was raving about it and using them. Okay? There was a time when the only work in front end, in web, was Angular. Okay? I have actively avoided those workplaces, and it has cost me in less opportunities. But that's okay. I don't know, it works for me. Follow your gut instinct. It is okay. It is fine to be opinionated. Years later, many have acknowledged the same problems I had identified, but couldn't really speak out, talk publicly about years ago. I think nowadays, with my current status, where I'm more senior, I feel more free to criticize and discuss these things. But as a junior or a mid-level developer, it's hard. It's hard going against the flow. It's hard saying, hey, this stuff which everyone is using, it's not good. Why are you using it? You need some balls for that, and it's tough. Now, when you're wrong, and you'll obviously be wrong sometimes, better late than never. It's okay to be opinionated. It's okay that your opinion will sometimes be wrong. Okay, you can always change your mind. So be opinionated. Never forget your core product, your priorities, your business domain, and your constraints. And always reevaluate your opinions, okay? It is okay to make mistakes as long as you do not ignore them and change your mind and change your direction and pivot and just rewrite and swap whatever it is that you thought is good, or maybe that was actually good but isn't anymore. That's fine. That's the nice thing about software. It is very easy to change, unlike almost all other fields of engineering. Change is cheap. On the same note, don't get attached. What's bad today can mature tomorrow. What's good today may become unmaintained and will inevitably be replaced by something better. Apply critical thinking and constantly revisit your decisions. Examples of my own mistakes. So who here hasn't liked JS6 back in the day when it launched? Raise hands. A lot of people. So did I. I did not understand it. I did not like it. It seemed like a step backwards. It seemed insane because we were taught certain misconceptions, which we can only say in hindsight that were misconceptions. Same thing I can say about TypeScript. So I am a late adopter of TypeScript. And TypeScript back in the day was a different beast compared to what it is today. And I just changed my mind because a lot of my friends have convinced me to try it, to give it a fair shot. And a whole lot of smart people whom I appreciate, whose opinions I value, have told me to try it, and I did, and I have even written about it, a blog post. So, set standards and enforce them using static analysis tools. Tools like TypeScript, ESLint, StyleLint, spell checkers, dependency graph analysis, which are good for catching, for example, circular tendencies, or all sorts of other issues. Editor config for cross-platform development when some of your team uses Windows and others are using Linux, Mac, whatever, and more depending on your selected tooling, stack, languages, whatever. But the trick is you do not want to limit or dictate to your team what editors or IDEs to use, because people are attached. People are effective where they feel at home. So some like Vim, others like VS Code, others like WebStorm and other JetBrains products. And you don't want to pull your developers out of their comfort zone. You want to keep them there. So related to that, reducing cognitive load. Use Prettier. You want your people to focus on business, on how to solve the problem at hand, not fighting over white space. Linters are a good thing. They find possible bugs, allow you to enforce style guides. Testing, also pretty obvious. They make refactoring easy and catch mistakes early. Context switching is expensive, and it's what amounts to cognitive load. Having a short feedback loop which shows mistakes live as opposed to committing and then waiting for your CI or for a code review or whatever, something to alert you, hey, you have this mistake. So having feedback in real time is crucial. The question is how? How do you do all of this? Because these guys aren't nice. And have you tried policing your team? It's just annoying. It never works. You'll be that guy who just polices everyone. And like, why didn't you run this? Why didn't you do that? It doesn't work. Following protocol, even with the best intentions, people are genuinely busy solving problems, delivering stuff, getting shit done. Having a procedure is a good thing, but if you can avoid that and instead have tooling, which is just there, and that is way better. Requiring everyone to use your favorite editor or tool or setup. I don't know, for example, I heard that JetBrains products, they have linting and stuff inside and refactoring, which is awesome, but I don't like them. I don't like an IDE, so don't force me to use one. I tried this. Fixing the world type of 1 million lines of code commit. So you decide to change some lint rule or some style guide, and then you just run your ESLint -- fix on everything, and it's basically your entire project, every single file. It doesn't work. It doesn't work even if you succeed to do that, because then you are the author of all the commits of the entire code base, and you're the one that Git blames. And also, it usually doesn't work because if you try to fix things and you're working obviously in a team, then others are busy delivering stuff, and you've changed some rules, but they haven't. You're going to have conflicts. It just doesn't work. So what does? Tooling which just works regardless of editor and IDE. Not having any manual setup or configuration ever for anyone in the team. You should have one person, or it doesn't matter. The point is there should be a single configuration which you can edit once, and then it is applied everywhere to everyone incrementally without anyone doing any setup. It has to be incrementally. It has to apply only to committed changes, not the entire code base or branch or whatever. And the nice thing that once you have this in place, the very same tooling which you can run on your development machine and provide live feedback will just run in CI because it's just shell commands. So how do we do that? We automate all the things. And these are your weapons of choice, at least in front end. NPM scripts, they just work because you have them built in with NPM and Yarn. They are installed as part of your dependencies. They are versioned. You will never have a problem where this person is running, I don't know, ESLint, and that person is running TSLint, and they are running different versions or different configurations. NPM scripts adhere to the Unix philosophy. They are single-purpose tools. They are composable, and they are cross-platform. They integrate very well with editors and IDEs using Node's module resolution. For example, every sane editor out there supports ESLint. So if you install VS Code or, I don't know, JetBrains or whatever, it has ESLint pre-installed with it, comes with it, built in, or maybe you need an extension. I don't know, for some tooling like Vim. But the point is, if you have a Node module installed, it will just look that up instead of using the built-in one. So that when you have your ESLint as part of your dependencies installed, your already existing tooling will just use that. Husky, the title is Git Hooks Made Easy. They are installed during npm install or yarn along with your dependencies, so you don't have to do anything to set them up. They are very simple. They just run commands which are just npm scripts and lint staged. Lint staged runs commands according to globs of Git staged files. So if, for example, I make a commit, and part of my commit, I have, I don't know, JavaScript files and CSS files, I can configure all of this tooling once I have added these two files to the Git stage. Then before committing, lint stage allows us to run one set of linters on the CSS and another set of linters on the JavaScript automatically without any developer doing anything other than what they do anyways, which is commit. And then if there's any discrepancies or issues, the commit will fail with the output of the linter. In the same way, you can run, what I usually do is I run the test suite and the build upon pushing, because the idea is you can have broken commits. So I change this and I change that and I change that. And I run static analysis on the contents of those files within the resolution of each commit. But maybe tests will fail, because usually, you know, or sometimes you can work in TDD, you can commit a test and then implement a failing test and then implement seed. And then you want that when you push code, it will be in a working state. So you run the build and you run the test suite. And if it fails, you can't push the code. On that note, be flexible. So enforceable rules, conventions, and guidelines are great. They are very important. Trust me. I'm a Nazi. Okay, everything gets linted, everything is scrutinized, but every rule has an exception. Here's a demonstration. Engineering is about managing trade-offs. When a rule doesn't serve you, just change it. Okay? You can ignore it in the offending scope, line, or block, or file. You can change the rule severity, and you can just disable the rule if you decide that it doesn't serve you. One of the things that I've seen at several clients is really crazy strict linting rules. And so imagine you're working and you're in the zone, you're in the flow, you have a million crazy context of a bug that you're exploring, or you're building some infrastructure, whatever. And then you do a terrible crime against humanity. You leave triggering space. And then your editor stops everything. Webpack doesn't compile. It shouts at you, you have done something terrible. And it just takes you out of that problem, and diverts your attention to something which is so not important and can be taken care of automatically. So that is bad, okay? The tooling should be there to serve you, okay? Most rules, most lint rules should be warnings. You should be errors which say, stop, you are doing something really bad. Reevaluate your choice. Next, refactor all the things. So there's been some, when I rehearsed this talk, a friend of mine told me that I should, that the word refactor is sensitive to some people because they perceive that it is something special. And it's not. Refactoring is just restructuring code without changing external behavior. It is changing the implementation details. Or, I don't know, just moving stuff around, renaming. That's also refactoring. It doesn't have to be, huge. Refactor and adapt as you go. It is not something special. It is not something that requires planning or tasks. In fact, it is an integral part of every developer's daily routine, each and every task. Refactoring is the air you breathe to keep moving. Here's a haiku I wrote about refactoring. Trying to program avoiding refactoring is painful failure. Proceed. An important note about refactoring architecture, because architecture a lot of times is perceived as something special, important, and I don't know, grand. It is just code, okay? It is not set in stone. It is not sacred. It should serve you just like the tooling should serve you. Just like the code, it should solve problems for you. It should evolve along with whatever it is that you're building. This is where I related to the Unix philosophy and where it a lot of times contradicts with frameworks. Architecture should be easily modifiable and replaceable. And this is where what frameworks are usually bad at, because they tell you how to do things, which is, it's not necessarily a bad thing. Frameworks enable you to get started very quickly and deliver stuff fast. But when you want to deviate from a framework's happy path, you're in trouble. I love this quote. So weeks of coding can save us hours of planning. Invest the time to analyze the problem. Yeah, duh. It's obvious. And still, it is hard to do. Try to avoid preferring what you know just because it is easier to use. Okay? It's really easy to fall for it. Choose the best tool for the job instead of the one that you or your team or your organization is already using or knows, is familiar with. So an example is choosing a framework or tool because blah, blah, blah. I have repeated that. A good example is server-side rendering versus single-page applications. If you have a content site, you don't need a single-page application. You need something like WordPress or Rails or, I don't know, whatever. It may not be a hip or cool choice, but it will actually deliver, and you will not have problems like SEO or, headaches. So choose the best tool for the job. Moving on, cultivating team and organizational culture. So software development is a team sport. And you need to invest in people. Doing that you do that by building trust with your people. They are your greatest and most expensive asset. You constantly need to give them technological freedom to allow them that, to let them have real involvement in product. It's tough to do. You need to give them a true sense of purpose. You need for them to care for whatever it is that you're building. You need to let them be independent. You need to challenge them. And perks like, ping pong tables or company lunches, they are nice, but they are the last and the least important ones for people. And what actually matters is the day-to-day routine, the stuff that people have to deal with on a daily basis. The meaningful things, okay, not the ping pong tables, or whatever it is that everyone sells nowadays. You want to make people want to stay. You need to encourage exploration, allow people to make mistakes, to learn and to grow. So I have a very good example for that from ages ago, back when I was working at my very first development role at Intel. We had this rule where whoever would screw up the database, would drop tables, or otherwise make it unusable, that person would bring a cake for the team. And I think it's a very, very good example of the kind of culture you want to have, because it celebrates failure. Okay? It shows everyone who made a mistake, what it was, but not in a shameful way. It allows people to feel, it leaves them with responsibility, but not with fear. Okay? Because, yeah, if I screwed up, I definitely don't want to do it, but I'm going to bring a cake now. Trust creates partnerships. People who feel that their work matters will naturally assume ownership, responsibility, and genuinely care for their work and your business and your product. You set the standard, your expectations, the way you give and receive feedback. Encourage and cultivate work habits will make or break your team, business, and product. So set an example. You need to listen and to empower. You need to encourage expressing concerns and opinions. You need to ask for feedback and actually listen to it, hopefully implement lessons learned from that feedback. You need to allow anyone to challenge any decision. You need to have each and every developer understand the reasoning for each and every task they are carrying out. If they think that what they're doing is a bad idea, they should speak up and open a discussion. Obviously, it can end with, back at Intel, it was called disagree and commit, but hopefully that is the very last resort. Nothing is set in stone. I repeat this with every single team and client I work with. Anything can be challenged and everything can be changed. Nothing is sacred. Let people do what they love. Hopefully, you hired smart people who do not need to be micromanaged. You need to supervise, observe, and learn people's strengths. So different people have different styles and are better at different things. Once you get to know your team very well, you can delegate tasks to those who will carry them out actually better than you. The key is you want to hire people who are smarter than you at certain things, and then just let them do their thing better than you ever will. Remote work. So if you want to hire good talent, or maybe outsource a project, get a consultant on board, why limit your options to the offices? Now, that is not to say that office work is useless or anything like that, not at all. The bandwidth, the eye-to-eye contact, the connection you get from sitting in the same room with a person and coffee breaks and lunches and, in person, it is irreplaceable. But you do not want to be limited to that. And I am not against offices. I am for also remote work. Why would you dictate where to work for your best people? Development is a creative process. It is not an assembly line. We are not factory workers. Okay? Our efficiency is not measured in time or schedule of whether I work 9 to 5. Feeling stuck in an office, but worrying about home because your kid is sick, or because, I don't know, you're not feeling too well, or because, I don't know, you have some shit going on in your life, is a recipe for bad results, for bad code, for, I don't know, grumpy people. Let people work when and where they will do their very best. Allow them to do that. I love this joke. I'm going to read it out loud in case it's not visible. So this is a climate summit. And the slide says energy independence, preserve rainforests, sustainability, green jobs, livable cities, renewables, clean water, and healthy children, etc., etc. And then a guy from the audience asks, what if it's a big hoax and we create a better world for nothing? So remote work is hard to enable, but the added benefit is that it creates an organization which is better functioning for everyone, including office people. And it allows you to onboard people a lot more quickly and to have better interactions between everyone. Mandatory code reviews. So for everyone on the team, always and no exceptions. Now, it's tricky. The feedback has to be constructive, meaningful, and not nitpicking. Tooling helps with this a lot, with the mechanics. So having a coding style which is enforceable, conventions, stuff like prettier. I've mentioned prettier before. Does everyone, can you guys, okay? All right, so most people know what prettier is. It's a code formatter. You tell it how to format code, and it runs, and it does that, and then there's no discussions anymore about new lines or white space. Static analysis with Git hooks allows participants to focus on what matters, business, and what the code actually does instead of how it, how pleasing it looks. Relationships are more tricky. People are more tricky. They're sensitive. They have feelings. And so here are some rules for code review when dealing with people. Again, some of this is pretty obvious. Needs to be stated. Be constructive. Assume good intent, not ignorance, not stupidity, not laziness. Be nice. How would you feel before hitting that submit button if someone wrote that thing to you? How would you feel about hearing that comment about something that you have worked hard on and is your best result, best shot at solving a certain problem? Use a proper tone. And I have to clarify, all of this is very important when doing asynchronous code reviews and remote code reviews. Because when you're sitting in a room with a person, it's easier. Just the tone of your voice and the body language speaks a lot of it for you. But when you're dealing with a form, a white web page, it's easy to forget that there's a person on the other side. It's also easy to, for your message to be misinterpreted. It's easy to be harsh, and it's easy to be heard harsh. So ask and discuss first and foremost. This should be the most of your comments, the most of the feedback. How can we improve here? Why did you choose this or that approach, tool, name, whatever? The next level is suggestion and guidance. I would do this. I suggest we try something else. And the very last stage, which should be used least, is instruction and commanding. We have to change this. This is not good. We need to modify this part. This will not work. Okay, this should be rare. Next, so with code reviews, you want to have early and iterative feedback. Have people submit and review pull requests early. You want to be able to catch the wrong approach to the problem at hand early. You want to catch serious bugs or design flaws or maybe some edge cases early. You want to minimize wasted time. And it is absolutely okay to review work in progress, even very partial and preliminary or exploratory work. It's okay. And it is okay to submit that for review, as long as you set the expectations. This is not ready yet, okay? Use labels or, I don't know, whatever tooling you want to communicate the status of the pull request and the code review. It can be work in progress, it can be a proof of concept, it can be ready, it can be in review, whatever. Asynchronous code reviews. So everyone and anyone can and should review others' code in their free time when they are at ease, when they're not worrying about any other task, when you're not pulling them out of their schedule, out of the bug or the feature or the whatever it is that they're working on, or maybe they just have a headache or a bad day, and then they'll just, they'll leave that in the code review. Have a look at this example of a pull request. Can anyone tell me what this is about? What it does? Or who is the author? What is this? Who is that? What is this nickname? I have absolutely no idea about, what even does this thing do? Why is this change? So asynchronous code reviews mandate clear documentation, having relevant context, and prevent time waste for peers. And this does not fly. So what does work is asynchronous code reviews set a record in clarity in every pull request. Anyone is able to understand, review, and test any feature or change without prior context. This is very good for your organization. If a feature goes through code review and design and whatever and is delivered and then shit hits the fan and you have a disaster, you have a clear record of what were the discussions. Why didn't the author, why didn't anyone from the code review identify this threat or risk? Okay, you can learn from it. So here's a good example. You see what the change is clearly stated in the title. You see who did this change. There's an image of a person whom you hopefully know. And you have the task that describes the business side and the mock-ups and the whatever related tasks of this pull request. You have the details of the work that was carried out, and you also have notes. This is descriptive. This is obvious. Anyone can open it, read, and understand what it does, what it fixes, what's the change, and why are we taking this approach. Now, all of this stuff that I've been talking about, I haven't invented. I have merely copied from the best, which is open source software. It is remote distributed, asynchronous, and always out in the open and in public view. Adopt and practice this workflow in your organization, and your developers will know how to contribute to open source, which, at least in my view, a lot of people want to do, but don't know how, and it seems intimidating and hard to, and difficult to start. Encourage them to contribute to open source, and they will love you, and they will know how to do that if you're already working in this fashion. And it definitely appeals to candidates when hiring, or at least the right candidates, in my opinion. Improving as you go. Code improvements should be in practically every single change. I like this quote: no matter how slow you are writing clean code, you will always be slower if you make a mess. See something unclear? Clarify it. Did it take you too long to find that bug? Ask yourself why. How can you make it easier for the next person? Don't do just the bare minimum, okay? Go the extra mile and demand it from your developers, from your teammates. And that's basically the Boy Scout rule. Leave your code better than you found it. In a code review, when I see something which I don't like, even though it is unrelated to the changes in the pull request, I'll often ask to fix that, because that code path will be reviewed and QA'd and deployed anyways. So why not fix something along the way, even if it's not part of the requirements? The question is, how do you actually do that? Because, you know, we all have constraints and schedules and worries. So ask yourself this: is now an emergency? Is the building on fire? Is the production, I don't know, is my business losing money? The answer is usually no, which means you can do more than the bare minimum. You can spend another few minutes to clean up, to improve. You can spend another half hour to leave things better after yourself for everyone else's benefit. The broken windows theory, it's, I didn't know this until a couple of days ago. A friend of mine introduced me to this concept. So if there's a broken window, then it's easy for its terminology. Then it's easy for people to, you know, vandalize more. Or if you see, I don't know, litter in the street, it's easy for you to toss your trash there. Do not tolerate that. Maintain 0 lint errors and warnings, 0 test failures at all costs, because even one will immediately turn it into 10, into 100, and then it's a lost cause, okay? This is very important. You know, if you're linting and the linter is yelling at you, you have 90 warnings, nobody's going to read that. It voids the whole purpose of the tool. It just wastes time and attracts unwanted attention. But when you have 0 bad signs and then one appears, you know that's your fault. You know you have to fix it. Managing technical debt. So obviously, we have to deliver sometimes quick and dirty or take shortcuts. You have to invest the time to pay back those debts and fix the faults. Don't let the bad stuff accumulate. Do not get to a place where you're only putting out fires. Again, it's obvious and easy to say, hard to implement, but it's the only right way to develop. Reduce the bus factor. So avoid having single domain owners. The bus factor is the amount of people whom, if run over by a bus today and get killed, your project, your business will cease to function after. It's okay to have experts and those who know some parts of your code better, but never get to a place where you rely on a single person whose work cannot be replaced by others. Make every part approachable and easy to understand and maintain. Document important details. Actively reduce the bus factor. You can shuffle people and tasks. You can move, introduce different people to different parts of the code base, which they have never touched before that. Get everyone involved with all parts of the code. Start with easy, simple tasks and expand from there. Set a policy which not only allows but encourages everyone to review anyone else's code for the millionth time this presentation, but it also helps deal with the bus factor, because when you read code, you know what happens even where you did not touch. Clarify it to your team why it matters. Most importantly, allocate time for it. Give people the opportunity to review code. It is important. People learn a lot from reading others' code. A lot of times you criticize someone and then you realize, oh shit, I do the same mistake. I just did that. And you learn about others and you learn about yourself. Git workflow. Our time is problematic, so I think I'm going to skip some. Establish a clear and easy to follow Git branching and PR process. Use branch naming conventions. A simple convention can go a long way and add clarity. So, bug fix / description of what is broken. Anyone can understand that. Feature, name of the new feature. Anyone can understand that. You don't need any more context. Create pull requests early and encourage everyone to review others' code for the millionth and one time again. Ask people, I usually do this, I ask people to start their day by reviewing code before they have committed to whatever it is that they need to do. So they're not bothered by things, and also not after lunch when everyone is tired and just watch cat videos on YouTube. Git is hard. Make sure developers know Git. It requires a non-shallow understanding to use it effectively. A lot of developers avoid learning Git and use a GUI, which poorly abstracts Git. Just to clarify, the problem is Git itself. It is a difficult tool. It is low level. It is hard to abstract it and to make it easy to use, which is why these abstractions are all leaky. And when faced with any non-trivial issue, when a person who does not know Git well is facing with anything which deviates from the happy path, they basically get stuck. They get to a point of basically panic, and then you have to look for the best person around who knows Git. Git is hard. I'm still learning, and it's been years. I wish I had better advice about Git, but my best advice is to encourage people to use the command line interface for Git and to actually not copy-paste, but understand what they're doing whenever they're solving Git issues and challenges. Related to that, teach people to make small, atomic, meaningful, and descriptive commits. ideally, each and every commit should be one that takes you from one working piece of code to another. It's harder to do that than to say, obviously. But we should all strive to that. Another good policy, a change per branch. So even if you have the same code path, two different changes, one is a feature and another one is a bug fix, when working in a team, which is maybe distributed, maybe they're asynchronous, maybe they're working on different tasks in different timelines, it is best to do a separation of concerns. Different branches, and when you need to integrate, you create a third branch. And when the two branches, the two features, the two change sets are closely related, Git will allow you to express that relationship by using a variety of tooling, like merging, rebasing, cherry picking, and using patches. The problem is that most people don't even know these tools exist. They only know about merging. Which brings us back to the previous point. Developers should learn Git. And I think I'm done. I really love this quote. Do not go where the path may lead. Instead, where there is no path, leave a trail. As a leader, I thoroughly believe in that. And I try to follow this advice. And thank you.